Hello, greetings of the day. I am Mrs. Vinaya Tapkir, Assistant Professor from MIT Academy of Engineering, presenting here the next topic for the mucous kernel, that is TCB tables. In the previous video we have looked out the TCB OS underscore TCB structure, which is written for the TCBs, So we have introduced the OS underscore TCB structure, which is written into the kernel in line with the C structures. Here now again we have to introduce the one more concept of the C language, that is a linked list. Now whenever we have seen that every task is having its own task control block, that is a TCB, and own stack. Task is having its own task control block when the task create function will call the OSTCB structure, and it will place the OSTCB structure into the memory as a memory block. Whenever the task is created, then the structure of the TCB will get placed into the memory, otherwise it is in the dormant state or it is in the ROM memory. Like in the C language, whenever we are creating the structure for any database, we are writing the template in the program, and when we are executing the program, then the compiler allocates the memory for our database into the memory as a physical memory. Okay, so when the structure will called, then the block will be placed into the memory as a physical object. So similarly here, when we are creating the multiple objects, in the last video we have seen the OS underscore maximum underscore TCB is the function, is the variable declared to give the maximum number of the tasks to be created, and that number will the it is helpful to create the TCB tables by the kernel. So we can understand that TCB table is forming one array. So all these are placed, that array of the TCBs is placed into the one array, that is called as a OS TCB TBL array. So we will have a, this is OS TCB TBL array. So this square bracket indicates this is a array. See, all the C concepts we are applying here. If C language is the prerequisite for this mucous2 kernel, because kernel is written in a C language. So we can better understand, this bracket indicates this is a array. So this array is known as a OS TCB TBL array. Because when we are forming one application, for that application all the TCB tables should be linked with each other, because they are created for same application, so that it should form a array, and that array TCBs should be linked with each other, and that is with the linked list concept. So see, this is the diagram. First we will go to the terminologies shown in the diagram. First is this TCB table is known as a OS TCB free list table. Okay, so what is this? The free TCB tables. When it is called as a free TCB tables, when these are not yet called for particular task, then all the tables are resides into the dormant memory or in the ROM memory as a free list table. Means it is not yet called for the particular task. That list is called as a OS TCB free list table. This free list table is having multiple variables. Look out that this is the OS TCB table of 0. So this is the 0th element of the OS TCB table. This is the first element of the OS TCB table, and this is the second element of the OS TCB table. These are nothing but the structure. These are nothing but the structures, and that structures are the OS underscore TCB. Now every data member of the OS TCB we have seen in the previous video. So here all that variables are present in the OS TCB. Only here we have highlighted the OS TCB next, which is also the one of the data member of the OS TCB structure. This is OS TCB next. So this is the element required to form the linked list formation of the OS TCB tables. Every OS TCB table of 0 is having the address of the OS TCB table of 1. OS TCB table of 1, this location is having address of the table of 2. so that all the TCB tables are connected with each other in a singly linked list manner. Actually, the previous address is also stored here. There are the two variables we have seen in the last video. In the structure, there are the two variables OS TCB next, which stores the next address of the TCB, and OS TCB PREV stores the previous address. So this is a formation of the doubly linked list table. So here we have highlighted only one variable here, but the previous OS TCB previous variable holds the previous address of the TCB table. So all the TCB tables, all the TCBs in the table are linked with each other in doubly linked list manner. Okay, so this is about this variable. Now what is this OS TCB free list pointer? This is the pointer address which is pointing to the particular TCB. So this is a pointer and it is denoted by star in a C language. You know, pointer variables, we are denoted by star. So this is a OS TCB free list pointer which points to the first 0th TCB so that the kernel can understand all the linked TCBs are now free to use. So whatever the TCB which is pointed by the OS TCB free list, after that all TCBs are in the free list. So now this is the OS TCB free list. No any task is created. Hence from zero, starting from zero to up to the last TCB, all the TCBs are free now. So maximum MuCOS2 can support maximum 64 tasks and MuCOS2 can support 2 system tasks. So MuCOS2 is having the ability to create the 64 OS TCB tables. OS TCB tables. Out of that means 0 to 63. Out of that 2 will be for the system task. Out of that 2 will be for the system task. Then 63 minus 2, there will be the 56. There will be the at most 60 to 61 tasks can be created for our application. So here from 0 to 64, all the TCB tables are in the free list now, unless and until we are creating any task or unless and until we are creating any application. So this is about this pointer. This pointer denotes the list of free TCB tables. Again, what is the address of the last TCB? OS TCB next last TCB will hold the address 0 because in the link list, last link should have the null value to indicate that this is the last node of the link list. So always the last TCB is holding the address 0 or null in the OS TCB next location. Now what is the meaning of this? OS TCB table, and this is the in the square bracket it is written as a OS underscore maximum underscore task plus OS underscore n underscore system underscore task minus 1. So let's have a look on this. OS underscore maximum underscore task. Maximum कितने task create कर सकता है हमारा MuCOS2? That is a maximum 64 task. Means 0 to 63, that is so it is creating the maximum 64 task. Then minus, how many system tasks will be there? 2 system tasks are there. So it is actually the 62 tasks are the maximum task, 2 are the system tasks. So total 64 tasks can be created by the MuCOS2 and minus 1. So last number of the TCB should be 63. Because the MuCOS2 can support 64 tasks, out of that 2 will be the system task. Hence, we can say that there are the 62 maximum tasks can be created by the kernel. 2 are the system task minus 1. So last TCB का जो number है, that will be the 63. So in the OS TCB table can form the array of 63 TCB tables from 0 to 63. And this last TCB is having the null address in the OS TCB next location. So in this way, OS TCB free list is the free tables, list of the free tables which can be created for the application, which can be called in by the compiler at the time of task creation. So this is all about all the variables in the free list tables. So Mucos2 allocates OS underscore n underscore sys underscore task. That are the two system tasks are there, which are for the internal use, because these are the system tasks, and that tasks are nothing but the idle task and statistic task. We have seen the definition in the previous video, what is the idle task and the system task, statistics task. Okay, we have to see the listing also in detail. I will create one video separately for the idle task and the statistics task. Okay, now TCB tables. We have seen about the TCB free list table and each and every pointer and each and every variable of the free list table. Now we have to see the one example. How many TCB tables can be generated by the kernel? So one example is there. An application needs suppose two tasks only, two tasks to accomplish the work. Then justify with the need diagram how many TCB tables will be allocated by the kernel. Means for this following steps to be followed, we have to go into the configuration file that is os underscore cfg.h file, and we have to set the variable os underscore max underscore task to the value 2. Then set the os underscore lowest underscore priority is a 3, because we are creating the two tasks. Two are the application task plus two are the system task minus 1. This is the formula which is seen in the previous slide. So it will give me the value 3. So maximum 0, 1, 2, 3. In such a way 0 to 3 TCB tables are required here. So the lowest priority task number should be 3, which is the priority of the our idle task. Okay. Then create the task. We have to create the task using OS task create function. This is also we have seen in the second video, OS kernel part 2 video. Task create, how the kernel is creating the task. Whenever the kernel is calling this create function, at the same time it calls the OS TCB structure and it provides the OS TCB list for the application. So what will be the diagram is in the RAM now. So see, this is the RAM. In the previous slide we have seen this is a free list. Now here we have seen this is a RAM. Now this is not a free list. Now one by one all the TCB structures will be physically called into the or physically present into the RAM. So I required how many TCB tables now for my application? 0, 1, 2, 3. Such a 4 TCB tables are required for the particular application as per the problem statement. So the first, this is the 0th TCB is for the task. First TCB is also for the application task. Then the second TCB will be the statistic task and the last TCB will be the idle task, because the lowest priority task is idle task and previous to that statistic task is there. So when task is created, the OS TCB pointed to the OS TCB free list. So in the previously, free list is pointing to the 0th TCB. Now the free list will free this table and it will call that table into the RAM. Again it will free the second table, first table, and it will call into the RAM, and it will shift the free list pointer to the another TCB which is free in the array now. So this is the actual memory block which is created into the RAM for our application, and this is the modified free list now. Now in the modified free list, the free list pointer will pointing to the OS TCB table of 4 now, because 0, 1, 2, 3 are assigned to the application task. So now the OS TCB free list pointer is pointing to the 4th table. Hence, after creating the one application, if the kernel has to develop the another application, then it will start creating the OS TCB tables from the 4th location. So in this way, the TCB tables are managed by the kernel using with the help of OS TCB kernel task create function and the structure OS underscore TCB. OS TCB free list is the free list available into the ROM, and actual RAM is having the OS TCB tables for the particular application. So this is all about the OS TCB table. So all of you should understand the purpose of this. different applications and how we can draw this RAM memory block for the OS TCB tables.